So in this video, we'll be going over ratio test. So when you hear the word ratio, what is the first thing that comes to your mind? Ratio is basically dividing two numbers, and in this test, we simply divide two consecutive series. Meaning, for example, let's say we have a of n, which is the first term, right? Since a of n is the first term, a of 10 will be the 10th term. And if you want to find the ratio test, let's take a of 10 and a of 11. We will simply divide the 11th term by the 10th term. But now, in series, we are always going to infinity, so we cannot have finite numbers. So we need to denote actually the number by n, and a of n is the nth term. Now, what is the next term after n? It will be n plus 1, right? So here, n plus 1 will be n plus 1 term, right? And that's it. So now, what we have to do is we need to divide these two consecutive terms. So let's take the limit as n is approaching infinity. We have the an plus 1 term over the last term, which is an, and we try to evaluate and get the answer. Let's call this L, but in many textbooks this is called rho, which is denoted by E, but you can call it anything like L, A, anything, doesn't matter. Now this L could be more than 1, less than 1, or equal to 1. If it is more than 1, this means a series is diverging. Now if you think about it logically, let's divide 9 by 8. We will get, if the numerator is larger than the denominator, we will definitely get more than 1, right? Which means that the numerator is growing or is more than the denominator. And that's exactly what we did over here. We have an, which is one previous series or term before this term. So if we can see that it is more than this means that we're adding, let's say, 9 plus 10 plus 11 until infinity, because this goes all the way to infinity, right? N approaches infinity. So that is why if the answer that you get is more than 1, it means that it is diverging. Oops, my bad. Now another important thing is that you have to take the absolute value of L, because let's say we have the last term a of n to be 8 and a n plus 1 is negative 9. So we are approaching negative infinity, which also means that it's diverging, right? So we could get a ratio of, let's say, negative 1.1, which is more than 1 if we take the absolute value. And it doesn't matter if you're approaching infinity or negative infinity, both of the answers are diverging. So that is why we take the absolute value of L. Now if it's less than 1, meaning that it's between 0 and 1, it means that it's converging, because we cannot have negative values for L anyways. So it has to be more than 0 and less than 1. So it converges. Now if the answer is equal to 1, this means that it is inconclusive, meaning that you have to try some other test, since the ratio test fails when the value is equal to 1. And another thing that you might notice in your textbooks is that your textbook might take the absolute value of this fraction over here instead of taking the final answer. It's the same thing, but sometimes it's more easier to take the absolute value at the start. And this basically is the ratio test. Now let's start with some questions. So our first question is, series of n is equal to 1 all the way to infinity. We have 2 to the power of n plus 5 over 3 to the power of n. So now let's write the formula first of all. Limit of n is approaching infinity. We have absolute value of a n plus 1 over a n. And Now let's write an plus 1. What is an plus 1 over here? We are just adding 1 to n, right? So an plus 1 will simply, let me just highlight the n's over here in the original fraction. If we want to write that plus 1, all we have to do is just add 1 to all the n's in the original fraction. So here, 2 to the power of n plus 1 plus 5. 5 stays the same since there's no n there. And over, we have 3 to the power of n. So it's going to be 3 to the power of n plus 1. Now, this entire part is an plus 1, right? Let me just write that over here. Plus 1. Now we have everything over an, the original thing. But what we can do is we can multiply this fraction by the reciprocal of an, because if we put it over here, it's going to be like very messy, right? So I just want to simplify things. I just gonna write an, the reciprocal of an, because it's gonna be this part. Okay, let me just write it and then it will be simpler. 3 to the power of n over 2n to the power of n plus 5, and this entire part is 1 over an. So now this is what we have. How do we simplify this? So the first thing that comes to mind is if we have 3 to the power of n plus 1, we can write this as 3 to the power of n multiplied by 3 to the power of 1, right? So let's do that over here. 3 to the power of n plus, or sorry, not plus, multiplied by 3 to the power of 1. And we can do the same thing over here. So this part is going to be 2 to the power of n multiplied by 2 to the power of 1. And we can cancel one of the 3 to the power of n. So let me just erase that actually. And here we cannot cancel 2 to the power of n because there is a plus 5 over here. So now let's just simplify and write the simplified version. And don't forget that we have a limit of n is approaching infinity. So now the final fraction would be 2 to the power of n multiplied by 2 to the power of 1 plus 5 over, I'm going to take 3 outside and into the brackets of 2 to the power of n plus 5. So this is the final thing that we are left with. So what can we now get rid of? What is completely negligible over here? What we can do is, as n is approaching to infinity, we can get rid of plus 5 because it doesn't matter, right? It's like infinity plus 5 because 2 to the power of n is like 2 to the power of infinity. And the same thing over here in the numerator. And this is just basically using L'Hopital rule. So now we are left with 2n, 2 to the power of n multiplied by 2, and 2n. So we can just cancel 2n, right? 2 to the power of n, sorry. So we're just gonna get rid of this. And now all that we are left with is just 2 over 3, which is the final answer. And as this is less than 1, this means that it is converging. So one thing to keep in mind is ratio test comes in handy when you're dealing with factorials. And I'll just show you in this question, next question, question 2. We have series of n is equal to 1 all the way to infinity. And we have in the numerator 2n factorial over n factorial multiplied by n factorial. Now, if you think about this, we cannot use any other test that we have learned, let's say DCT, LCT, P series, geometric, anything else except for ratio test. In our last question, we could have used what is called LCT and compared it with, let's say, 2n over 3n, and then find which is less or more than, and then draw the graph and so on. In my last video I explained LCT. But in this question, we cannot use any other method. So that is when this test comes in handy and you have to use it. So now let's start with this question. Let's write limit of n is approaching infinity, and we have an plus 1, the next term of this one, over an. Now let's write an plus 1 first, and let's identify the n's in the original fraction. So it is going to be, open brackets, 2, and there is a n over here. So I'm going to open the brackets again. N plus 1, it's very important because you cannot write, or you really need to be careful of the factorial over here. So if you can see, there are brackets between 2n and then the factorials outside. So this means this factorial is on 2 also. So that is why we need to be very careful here. And now we need to close the brackets and then factorial. So we just added 1 to the numerator n, and now let's go in the denominator. There are 2 n's over here. So now let's do them. So we have, open brackets again, n plus 1 factorial multiplied by the same thing again, n plus 1 factorial. And now let's multiply it by the reciprocal of the question, original question, since 1 over n is basically, I'm going to write it now, it's going to be the flipped of this part. So n factorial over 2n close brackets factorial. So now how do we simplify this? So let's quickly do a recap of factorials. 5 factorial can be, what is 5 factorial first of all? It is 5 times 4 times 3 times 2 times 1, right? So if I want to write 5 factorial, we can also write it as 5 multiplied by 4 factorial, right? And we can also write this as 5 multiplied by 4 multiplied by 3 factorial. So that is the logic I'm going to use here to simplify this answer. But first of all, let's simplify the numerator over here. So we have 2n plus 2. So I'm just going to write that over here. 2n plus 2, and the factorial is outside. So if I want to use this logic over here to simplify this numerator, it is going to be 2n plus 2 first multiplied by 2n plus 1, we are decreasing by 1, and multiplied by 2n factorial, right? Because the thing that we want to do is we want to get the numerator, or sorry, the denominator over here, so that we can cancel this part with this part. And we have done that now. So let me just erase this. It's going to be a 1 over here, and this entire part we can erase it now and just write 2n plus 2, 2n plus 1. Oops. So now let's do the same thing for the remaining denominator and numerator over here. So n plus 1 can be written as n plus 1 into n factorial. Or sorry, let me just write that factorial inside. And this factorial can be cancelled, n factorial can be cancelled with this part, and the same thing over here. So we are going to be left with n plus 1, n factorial, and then cancel this with this. All we are left with is n plus 1 multiplied by n plus 1. So let me just get rid of this. And now let's write the final thing. It's going to be limit of n approaching infinity. We have 2n plus 2, 2n plus 1, and then in the denominator we have n plus 1 into n plus 1. Now we can use the L'Hopital rule now. So what is the highest degree and the coefficient of the numerator here? Is going to be 2n multiplied by 2n, right, which is 4n squared over, and in the denominator is going to be n multiplied by n, which is n squared, and this is equal to 4. And 4 is more than 1, meaning that this diverges. So it's really important to remember the factorial rules and simplification, of course, and the L'Hopital rule and so on. One common question that students have is, when do we stop simplifying the factorial? Here we stopped at 2n because there was a 2n factorial in the denominator over here, so that is why we stopped at 2n over here in this part. I had 2n plus 2, 2n plus 1, and then 2n factorial, the entire thing. And this entire thing, 2n factorial, just cancelled out with this part. So that is why we stop at this. And that's how we know when to stop. And the same thing goes over here. We had n factorial and we had n plus 1 factorial. And that's there. So now let's do another example, another question, which is more complex. So we have series of n is equal to 1 all the way to infinity. We have n squared into n plus 2 factorial over n factorial into 3 to the power of 2n. So this looks overwhelming at start, but now let's start slowly doing it. So let's write a n plus 1 first. So it's going to be limit of n is approaching infinity, a n plus 1 over a n. So let's start now. Let's identify the n's in the numerator. The first n is n squared. So let's write that n plus 1, we have to add 1 to every n squared, and then we have n plus 1 plus 2. Since there's n plus 2, we can just write this as n plus 3 factorial over, we have n factorial, so that's going to become open brackets n plus 1 factorial, and the last one is 3 to the power of 2 multiplied by n plus 1. Remember that we are adding 1 to all the n's. If there is a 2 behind it, this means that we need to use brackets, because if you write 2n plus 1, that's not the same thing as 2 into n plus 1. You can see the difference. So let's just simplify and write this part. It's going to be 2n plus 2. I just distributed it 2. Now it's going to be multiplied by the reciprocal of a n, which is n factorial 3 to the power of 2n over n squared into n plus 2 factorial. So now let's start simplifying our answers. The first thing that I can notice is we can write this as n plus 1 into n factorial, and we have n factorial over there, so this just cancels out. So I'm gonna just write this n plus 1, and we can just erase this part. Now next part is gonna be this over here, so n plus 3 into n plus 2 factorial, and this part cancels out with this part, so we are left here with n plus 3. And let me just erase this. Now we can write this part as 3 to the power of 2n multiplied by 3 to the power of 2, and this is normal exponent properties. So 3 to the power of 2n can just cancel out with 3 to the power of 2n over there, so all we left with over here is 3 to the power of 2, which is going to be 9. So I'm going to write 9, and this entire part just becomes 1. Now the last thing that we can simplify is we have n plus 1 squared over n plus 1. So this can be cancelled out, and we have just 1, n plus 1 to the power of 1, which is just n plus 1. So now let's write the final expression. Is going to be n plus 1 into n plus 3 over 9n squared. And remember that this entire thing is approaching, n is approaching infinity. Now once again we have the same degrees of the numerator and the denominator, so therefore we can use the L'Hopital rule. It is going to be the numerator highest power is n squared over 9n squared, which is going to be 1 over 9, which is less than 1, meaning that it converges. So now let's do our last question, question 4. We have the series of n is equal to 1, infinity. We have in the numerator 4 to the power of n multiplied by n factorial multiplied by n factorial again, all over 2n brackets factorial. So let's start with our test, ratio test again. Let's find n plus 1 term, or n plus 1 an plus 1, sorry. So it's going to be just plussing 1 to every n again. So let's take the limit of n is approaching infinity. We have 4 to the power of n plus 1, open brackets n plus 1 factorial, again n plus 1 factorial, all over. Now you need to be careful again here. It is going to be open brackets 2 into n plus 1 close brackets, and then again close brackets factorial. Now we can just simplify this. It's going to be 2n plus 2. So I'm going to do that right now. 2n plus 2 multiplied by the reciprocal of the original question, sorry. 2n factorial over 4n, 4 to the power of n factorial, n factorial. So once again, take a moment and try to simplify this yourself. I'm going to do it right now. So the first thing, or let's just simplify this part over here, is going to be 2n plus 2 multiplied by 2n plus 1 multiplied by 2n factorial, which is going to cancel out over here. So I'm just going to do that directly. And here we have 4n plus 1 to the power of n plus 1. So let's just simplify this now. It's going to be n plus 1 multiplied by n plus 1, and these two just cancel out. And here we have 4n, and again we can write 4 to the power of n plus 1 is equal to 4n multiplied by 4 to the power of 1. So this part just cancels out, and we are left with 4 to the power of 1 multiplied by this, and this cancels out. So what is the highest power of the numerator? Is it going to be 4 multiplied by n squared? I'm just doing this quickly because you will see why. And in the numerator we have 2n multiplied by 2n, which is also 4n squared. So we get an answer of 1, which, if you remember from the start, means that it is inconclusive. So you might face this issue also. In the end you will get 1, and this means that the ratio test has failed. So yeah, so let's try another method, and let's just see the behavior of the question. So let's just try putting some values. N is equal to 1, n is equal to 2, n is equal to 3. So just try typing it on your calculator. Just substitute n as 1. You will get the first term an, which is going to be 2. Now if you substitute n as 2 over here, which is a2, second term, you are going to get an answer of 2.6 approximately. Now if you try n is equal to 3, you will get an answer of 3.2. So you can slowly see that we are increasing at a rate, and each time the next term is getting larger, right? And you can also see that we have an exponent, which is 4 to the power of n multiplied by 2 factorials, and in the the denominator, we only have 2n factorial. So of course the exponent multiplied by the factorials is going to be larger. It is going to be growing at a larger rate than the denominator over here. So if you can see this and you can prove this, this means that this is a diverging sequence, meaning that it is a diverging series. So a few things to remember is when you have an exponent and the power is increasing, here let's say it was 4 to the power of n and n is increasing or is approaching infinity, it is always, this function is always more than factorial. And that's one thing to remember. So here we know that the numerator is growing faster than the denominator, and we can see that also. And you have to also like try maybe till 5 terms or 10 terms and keep seeing the behavior, but you will always see that it's increasing. So we have a diverging series. So that's all for this video. I hope that you understood this topic, and if you have any questions you can ask in the comment section. I'll be more than happy to answer, and thanks for watching.